I'm here at the UK Snakeboarding Championships to do some maths and hopefully learn a few tricks or two. I mean, I might not be up to competition standards yet, but I'm not here to compete. I'm just here to collect data and compile some vital statistics. And I don't mean their inside leg measurements. Oh!
Whereas that's exactly what I'm going to do. I'm at the UK National Sizing Survey, where thousands of people are going under the electronic tape measure to suss out the shape of the nation. Today, Maths for Real is about analysing data using cumulative frequency. Keep watching, because all will be revealed.
These guys are using lots of maths without even realising it. I went along to meet Rick Lowe, one of Britain's highest flying snakeboarders.
Now, Rick, you're here to compete in the UK Snakeboarding Championship. I've been out there, so I know it's tough, but sort of how tough a competition is it going to be?
It's going to be really hard, really hard, especially because of all the international guys that have come.
I've seen them out there do a few tricks. How exactly do they score points?
Basically, you know, obviously the more difficult the manoeuvre is, the more points you get.
How are you going to do today?
I'd like to come in the top, probably, maybe the top quarter.
And while Rick's off doing flips, spins, grabs and grinds, I'm here to take a closer look at the competition scores. And for that, I'll be using cumulative frequency to see if Rick makes it into that all-important top quarter.
It's time to get my hands on the numbers, after the last of the competitors bites the dust.
56 people competed, so the scores on the boards look like this. The number of people who scored from 1 to 15 is 2. 6 people scored from 16 to 30. 19 people scored from 31 to 45, and so on and so on. But this programme is about cumulative frequency, which means I need to add another column to my table. Cumulative frequency is like the running total. You add up the frequencies as you go along and you get the total so far. Here, the cumulative frequency is 2. Next, it's 2 plus 6, which is 8. Next, it's 2 plus 6 plus 19, which is 27.
48, 55 and 56.
You can check you've done your sums right, because the number here, the final cumulative frequency, should be the same as the total number of competitors, 56. If it's not, you've done your sums wrong somewhere.
And to find out if Rick is in the top half, or even the top quarter, I'm going to start by drawing a cumulative frequency graph.
There's a few things you need to remember. Cumulative frequency is always plotted on the vertical axis. And the other variable, in this case the score, goes along the horizontal axis.
Next, plot the highest score in each class interval against its corresponding cumulative frequency. Join the points and you end up with a nice smooth curve.
But there's more. Over to Katie for some statistical analysis.
This is Jamie's cumulative frequency graph. Now, 3 of the things you'll be asked to estimate from a graph like this are the median, the lower quartile, and the upper quartile. The median is the middle value of your data. In this example, it's the score which half of the competitors exceed and half don't reach. To estimate it from the graph, first find the total number of values in your data. That's the highest value the curve reaches up the vertical axis. If I read back to the vertical axis, that's 56. Next, find the position of the middle value. Strictly speaking, you do that by using this formula, where n is the total number of values. In this example, n is 56, plus 1 gives 57, divided by 2, which is 28.5. The median is the 28.5th value. When you're handling lots of data, it's reasonable to approximate, and a good approximation is to not bother with the +1 bit. Simply divide 56 by 2, which is 28. To estimate the median from the graph, travel across from 28 until you reach the curve, and then down to the horizontal axis, and the median is 46. Next, the lower quartile. This is the value which is 1/4 of the way into the data. To find the exact position of the lower quartile, you can use this formula. 56 plus 1, 57, divided by 4 is 14.25. Again, you might decide that it's sensible to approximate. Drop the plus 1 and simply divide 56 by 4, which gives 14. To find the lower quartile, travel across from 14 until you reach the curve, and then down to the horizontal axis. The lower quartile is 36. Finally, the upper quartile. The upper quartile is 3/4 of the way into the data. Its exact position is found using this formula. 3/4 of 57 is 42.75. Or, to keep things simple, you can approximate by finding 3/4 of 56, which is 42. To find the upper quartile, read across from 42 on the vertical axis, and then down, so the upper quartile is 55. For Rick to have had a good competition, he ideally wants to be above this upper quartile. So, how did he get on? Actually, he was way above the upper quartile with the day's top score.
2001 UK champion is Rick Lowe.
OK, this is the bit where Katie and I both tackle a typical maths question, but only one of us does it correctly.
The other makes a deliberate mistake, which you have to spot. You decide. Do you tick it or trash it?
The table gives information about the marks scored by 25 people in a maths test. On the grid, draw a cumulative frequency graph and estimate the median mark. Pens ready? Let's go.
Use the data given to draw a cumulative frequency graph and estimate the median mark. I plotted the upper value of each interval against the cumulative frequency and got a graph that looks like this. The median is the middle value of the data. To find that, I took the highest value of the cumulative frequency from my table, which is 25. I added 1 and divided by 2 to get 13. The median is the 13th value. To find that, I read up from 13 on the horizontal axis to the curve and across to the vertical axis, giving me a median mark of 5.
Now, I plotted the same graph as Katie, and to find the median, I also started by taking the highest value of the cumulative frequency, which is 25. Added 1, divided by 2 to give me 13. To find the 13th value, I read across from 13 on the vertical axis to the curve and down to the horizontal axis, giving me a median mark of 18.5.
So, whose working should you tick and whose should you trash?
Was Katie right to read up from the mark and across to the cumulative frequency?
Or was Jamie right to read across from the cumulative frequency and down to the mark? OK, it was me who made the mistake. I got the first bit right. The median is the 13th value, but I read that value off the wrong axis. I was asked to find the median mark, so I should have read my answer from this axis.
It's been over 50 years since the last national survey of women's body sizes was conducted. And do you know what? There's never been a proper survey of men.
Well, a new £3 million survey called Size UK is measuring over 10,000 people to record the body shapes of modern Britain so that shops can give you fashion that fits better. I volunteered to take part, so I'm at the London College of Fashion to see if I've got what it takes. But there's hardly a tape measure in sight. Instead, they're using the latest high-tech body scanners. You simply step in the booth, and a virtual tape measure takes up to 130 measurements in a matter of seconds. The idea is to use all this data to generate statistical models of today's population. Sue, you're from one of the biggest high street retailers. You've done a similar survey before, you did a smaller survey. What kind of information were you looking for and what kind of measurements did you take?
We were just hungry for the data, and in the last survey, which was done in 1996, unfortunately again it was only women, 2,500 women, and this time round we were looking really for their size, their shape and their actual measurements so that we could create clothes to fit them.
And you must have collected a lot of data.
A massive amount of data. And this really represents just a small amount of the analysis that we've done.
I've used Sue's data to create this cumulative frequency table. I've only used measurements for 16 to 30-year-olds, and the single measurement I'm looking at is for inside leg. And when I plot this data, I get a cumulative frequency graph that looks like this. Remember, cumulative frequency always goes on the vertical axis, and the measurement always goes on the horizontal axis. Okay, now for some analysis. The three vital statistics we can estimate are the median, the lower quartile, and the upper quartile. The median is 69.5. The lower quartile is 66.2. The upper quartile is 72.7. From Sue's original data, I know that the lowest measurement is 57.7 centimetres and the highest measurement is 85 centimetres. These 5 numbers can then be used to summarise all the data in a simple diagram called a box plot. First, draw a horizontal scale. Then, above the scale, mark out the position of your 5 numbers with a short vertical line. Doesn't matter how long it is. Now draw a box or rectangle. The left side of the box is above the point corresponding to the lower quartile, and the right side is above the point corresponding to the upper quartile. The line inside the box is the median. Now all you have to do is draw a line joining up the minimum value with the lower quartile and the maximum value with the upper quartile. This is also known as a box and whiskers diagram. The box itself indicates the location of the middle 50% of the data, also known as the interquartile range. And the whiskers show the overall range.
Different shops target different age groups, so one thing that retailers are interested in is whether body shape changes with age.
This is the same as the box plot I've just drawn. It's the inside leg measurement for 16 to 30-year-olds. And this is the box plot for 31 to 54-year-olds. When you put them side by side like this, it's easy to see how the middle 50% and the overall distribution compare. Let's see what Sue has to say. So what does this box plot tell you?
Well, the first thing it tells us is that it proves that there is actually a 2 centimetre difference in the median between the 16 to 30 age group and the 31 to 54 age group. And in effect what it's telling us is that actually we do need longer length clothes for younger people.
So what have you done about that?
Well, we've used this data and we've coupled it with lots of other bits of data to actually give us the right sizes and shapes to our tall girl range in our stores.
So the Size UK survey, which you're still waiting for the final results from, could have a real impact on the high street.
Yes, I'm sure it will have. We're really excited about being able to play with that data.